In this video, I'm going to show how the Gloo Platform management plane can be deployed to multiple regions and have automated failover between those regions. I'll be using AWS with clusters deployed to 2 different regions, connecting to one management server at a time in an active passive configuration. Let's take a quick look at the components used in the demo. I'm not going to deep dive on the architecture or multiple management server requirements. You can check out our documentation on solo.io, and all of the demo code that we're seeing here is actually available in a public GitHub repo in the solo.io org in GitHub. You can find a link to that repo in the YouTube comments below. So a very brief tour. Some of this will be explained in more detail as we go through the demo steps, and I'll refer back to this diagram as we progress through the failover steps. First, we're using 2 regions, US East 1 and US East 2. Each region has a workload cluster. We're not going to deep dive on the data plane or cover the data plane in this demo, but there is live traffic going to the data plane in an active configuration between the 2 regions. Next, we have the Route 53 failover record. This is the DNS record that determines which management server is currently active. Next, we have the 2 management servers, one in each region. We're using Argo CD to sync our management server configurations to both clusters between the 2 regions. And finally, we have the AWS Elasticache global data store that lets us have a shared Redis across 2 regions. You'll also notice a Lambda deployed to each region. This exists because AWS doesn't have an automated way to perform a failover between the primary and secondary in the global Redis data store. You can find a link to the GitHub repo for the Lambda Redis promoter in the YouTube comments below. Let's take a look at the starting state before failover occurs. This is a split view of the US East 1 dashboard on the left and the US East 2 dashboard on the right. As you can see, the beginning state is that US East 1 is the active management server and the agents are connected. Let's take a quick look at the graph. I just want to highlight that there is active traffic hitting the data plane because in the demo, we'll show that the data plane is unaffected by the management plane failover. Finally, let's take a quick look at the Gloo resources configured in this cluster. The traffic in the data plane consists of one route table that has 2 routes. One is a direct response and the other is a route to HTTP bin. Before we simulate a failover, I want to show evidence of how things are currently configured in the AWS environment. So let's start with the failover record for the management plane. The DNS name is management.hademo.vpc, so we can see here there's a failover record set with the primary and the secondary. Each one points to a network load balancer that sits in front of its respective management server. Here are the dig results for each of those network load balancers and for the management endpoint, showing that it is pointed to the US East 1 region. Now let's simulate a regional failover of the management server. I'm going to do this just for demonstration purposes by scaling the management server to 0 in US East 1. This will cause the health check for the load balancer to fail, which will in turn cause the AWS Route 53 record to fail over to US East 2. So the first bit of evidence I want to show that failover occurred is showing the agent connections in the Gloo Platform dashboard. This is the starting state where the Gloo Platform UI isn't aware yet that the agent's disconnected. And now we can see the agents have disconnected from US East 1. And now they've connected to US East 2 on the right. Overall, that process in real time took about 1.5 minutes to complete. Let's take a quick look at the agent pods and the workload clusters. One of them shows a restart, but that was from the beginning of setting up the cluster before I even started the demo. So both of these pods were up and running before the demo started. They have not had restarts and they are currently healthy. Here's a view of the Grafana dashboard for the data plane. So a lightweight load test has been running throughout this process. So this time slice is from when the failover occurred. We can see that the data plane was uninterrupted and there are no errors. Now let's go back to our terminal where we did our dig commands to see what the management API resolves to. Here we can see that the management API is now resolving to the load balancer in US East 2. Now let's take a look at our global Redis data store and see what's going on there. We can see that the Lambda has promoted what was the primary instance to be secondary, and now the secondary is primary, meaning that US East 2 is now the primary read-write instance for the global Redis data store. As further evidence of how that Redis promotion happened, this is a log line output from the promoter Lambda that promoted secondary to primary in US East 2. For the final bit of evidence that we've had a successful transition to US East 2 and that we're fully operational, meaning that we can continue to push Gloo Mesh configuration changes, I'm going to show adding a new route to the demo API that's been running in the data plane. So here I can see in the terminal that the /foo route does not exist. Now I'm going to copy my sanity direct response route and add a new route called foo with the prefix foo. And I'll just replace the message with a message indicating that we just added a new route. So I pushed that new route up to GitHub and it was synced to the currently active management server in US East 2 with Argo CD. Now I'll just go back to the CLI and try that foo route again to demonstrate that it was picked up and is actually being served by the data plane. And we can see on the command line, the curl request now is showing the direct response that we just added and pushed up saying this is foo route. That concludes the demo. I hope you enjoyed it. You can check out the source code used for the demo in GitHub. It contains Terraform artifacts to build out the complete 2-region 4-cluster configuration and install Gloo Platform. Links to the GitHub repo and the companion blog post are in the YouTube comments below. Thanks for watching.